students to directing class. As you know, we only have 2 days left in the class, and so for a final project, you guys have to do a research on anything that interests you. Yes,
How much is it worth?
it's worth 69% of your grade. So you gotta take it seriously.
So what can you do it on?
Anything, because the academic system bores you. It beats your curiosity out of you. So I want to spark that. So you can do it on anything, but has to relate a little bit to film.
Okay. Do you have an example of what to do?
You can talk about how cameras are made. That's one example.
Okay. Do we work by ourselves, or do we get like another person to work with us?
Well, you have the option. You can work in groups of 1 or 2, but no more than 2.
Okay. All right. Okay.
Okay.
I still need more information for my project. Maybe I should ask my grandpa. He's been around for a while, so maybe I'll go ask him. Grandpa, over here.
Oh, hey Sean, what's up? You said you needed help?
Yeah, so I have a film project to do, and my project is on the evolution of cameras. And I wanted to know, what was the first camera like for you?
Oh, I remember. I was right around your age when the first photographic camera for commercial use was built by Alfonso Garrix in 1839.
How much was it?
It was 400 francs.
Were you able to buy it with your family?
No, we were really broke, dude.
Oh.
Yeah.
Well, what did it look like?
It looked like this.
What?
So this is what the first camera ever invented looked like, which was invented by French inventor in 1816, Nicephore Niepce, and it looks pretty old and very big and bulky, very inconvenient to carry on places. However, this is the one I was talking about. This is the one made by Alfonso Garrix in 1839, and this was actually made in bulk in mass factories to be sent out for commercial use.
So what Grandpa told me was very interesting, but I'm wondering, how did you get from what he told me, the first camera, to all the way to this?
You're such a beautiful tree.
Get a load of this guy.
Oh, hey.
Oh,
What's up?
oh hi.
You like cameras, huh?
Yeah.
Yeah. What you doing with the camera?
I have a project to do, and it's about the evolution of cameras.
Evolution of cameras.
Yeah.
Did you know that in the 1960s, in the hipster era, they used monochrome black and white cameras like the Kodak 20?
For real?
Yeah, you can actually go over there. My friend can explain it to you.
Okay, I'll trust what you say,
All
but
right,
thanks,
yeah.
man.
Hello, Sean. So I heard that you wanted to learn more about making your darkroom print, so I'm really happy to provide that for you. Right now, I've prepared all of the materials, and we're about to get started. So let's go. So we can see we have the developer, we have the stop solution, and we have the fix solution as well. And now this goes into detail about modern processes, which are different from the traditional ones used earlier. However, for the simplification, we'll just skip forward to So there you go. That's how you make your darkroom print. It's fairly simple, yet not so simple. I hope you had a great time. See you later. Bye.
You know what? That was very insightful. But I really want to know the chemistry behind film photography. Hey, are you Dr. Jeffrey Smith?
Yes, I am.
Oh,
Nice to
really?
meet you.
I heard from like a random hippie actually that you were actually a leading chemist in film photography, and I was wondering if I could get any help from you.
Yeah. You want to know how it works?
Yeah.
All right, perfect. So basically, okay, so the camera itself has many layers, which is very important. The first one is scratch resistance, because you don't want to have any scratches on the lens itself. Then you have the emulsion layer. This is very important. This is what helps capture the picture. It's actually made up of gelatin, and it has impurities called silver halides. These halides are usually silver chloride, silver iodide, or silver bromide. Most common is silver bromide. Then you have the adhesive layers, which is just plastic and helps keeps it in place with the film base. And then the anti-halation layer, and this absorbs the light and basically prevents reflection, so you don't really get the glare in your pictures. All right. So the most important layer is the emulsion layer. That's where the bulk of the chemistry is. So, like I said, it's basically made out of gelatin, and it has impurities such as silver bromide, and this basically traps the light energy. Okay. So if you were to take this and zoom in, the reaction, so the light energy would come in and it would capture the light energy. This would cause bromide ion to lose an electron, which would travel to the silver ion. Now, once that happens, it turns into a silver solid, or solid silver, okay? And because of that, you get a bunch of clumps of black ink, basically. And now, that's invisible to the naked eye. So you take it to the dark room, where there's red light. Why red light? Because red light on the visible spectrum is the weakest. It has the longest wavelength, therefore it's the weakest, and you need more energy to knock off an electron, so it will protect the image. It won't alter it as much, right? So into the dark room, you have a developer solution. Now, developer solution, it basically causes this redox reaction, so we can basically clean the image, and then you put in the stop bath. Because the developer solution is a little bit basic, you need to neutralize it. So the stop bath is usually acidic a little bit. After you do that, you go to the fixer solution, and the fixer solution basically locks in your image, and you react it with this to get that. And so basically this is the negative image. So the lighter pictures will be darker and the darker pictures will be lighter. It's an inverse, right? And so you put that next on top of a photographic film and put it to visible light, where the copy will be copied onto the photographic film, and it'll be the positive, and that's where you get your black and white picture. So that's an oversimplification of how film photography works. You got it?
Yeah.
That's cool.
Thank you.
Yeah, you're welcome. Nice to meet you.
Thank you.
Have a good day.
Well, I know that the digital cameras are now the trend and film cameras are not used anymore. But I wonder why digital cameras are more useful than film cameras. Well, it says here is that digital cameras have the advantage of being able to change film speeds between individual photographs. As for film cameras, traditional film must be developed in a darkroom, and the process is very time consuming. There's also the chance of ruining your photos, and if undeveloped film is exposed to sunlight, your photographic images will be washed out. But also, there's higher long-term costs. The years of buying a film can add up and ultimately make analog cameras more expensive than their digital counterparts. Shooting film into memory cards is far more economical than buying rolls and rolls of film. Here's my idea. I basically want to show the history of the camera using the 3 different cameras that are essentially the timeline parts of how a camera was developed into what we have now. And so basically, the first one, I actually had to go to my grandpa. I asked him about what like an old camera looked like, and what they did, and how it would look like on actual paper and stuff. And then after that, I actually went and met Hippie, who actually told me about how they used Polaroid cameras and how they were able to make basically a photograph of something, and then make it into actual physical copies of it. And then finally, I actually was able to meet with a chemist who gave me an actual breakdown of the chemistry behind film photography. And finally, that's where I've decided that, oh, I can even use my own camera to make my own films, and this is basically what I want to do for my film. Is that good?
So basically the evolution of the camera.
Essentially, yeah. I
Okay.
think so. And I was able to meet good people that could help me with what I wanted to do.
That's good. That's good.